My name is Joshua Lessing, and I'm the Director of Research and Development at Soft Robotics. So I have a rather unconventional start in robotics. I'm actually a chemist by training, and I came into robotics when I started my postdoctoral work with Professor George Whitesides at Harvard University. And George Whitesides, he is one of the world's most famous chemists, and he not only does work in chemistry, he really just does work in anything that he finds interesting. He's very, very innovative. And so when I was in his lab, he was doing robotics, he was doing composites, molecular electronics, water protein interactions, the origins of life even, anything that he finds interesting, he works on. And he builds these cross-functional teams that are designed to come up with new ways of thinking about age-old problems. So in the case of Soft Robotics, he had people who were chemists like myself, chemical engineers, people who understood biomechanics, you name it, most of which were not conventional roboticists. Try to think about what would be a new way of building a robot. And where we got to was, if you build robots out of rubbers and plastics and other kind of squishy materials, liquids, you get robots that, astoundingly have all these new properties that are very, very interesting. So that was some of the stuff that I worked on in his lab. And when it came time to commercialize the technology, I left to start that here with Soft Robotics. I've spent my career trying to do bio-inspired research. So early in my career, it was trying to develop biomimetic catalysts so that the oil and gas industry could turn methane into ways of making nylon. Later on in my career, it was trying to study the fundamental molecular properties behind elastin, which is the rubber that makes up the soft robots that are people and animals, and it's a remarkable material. So nature made the best rubber. How do we replicate it? And so moving here to the work at Soft Robotics, nature has made the best gripper ever conceived. What can we learn about these biological systems, and how can we incorporate their design principles in the things that we make? Just because they're remarkable. There isn't an incredible amount of computation that goes into the use of your hand, not the kinds of computations that most roboticists are accustomed to in the systems that they build. But yet, miraculously, you can do far more with this than you could with a normal robotic gripper. And part of that is embedded in the mechanical design. The muscles and the tendons and the bones, all the stuff that's in compression, all the stuff that's in tension. That whole mechanical structure, a lot of the smarts are just built into how it innately responds to the environment, even without active controls of moving your muscles. So what's exciting for me is having this possibility of delivering this astonishing capability of getting ever closer to this style of grasping through the technology that we work here to build every day.